Aloha, Richard Halverson here. This is ICS321, and today is June 2nd. And that's the second video, I think. Let me share my screen. And so ICS321, let's see. One of the things that I did, let's look and see where I am and where we are at the syllabus, because it sort of matters a little bit. We are in 6.2. Oh, so we're over here, and we should have. So I'm going to talk about this today. You know, I tell you what, I'm going to briefly go over. I haven't talked about this thing yet. Today's 6.2. Okay, so really, it's like this one. Yeah, so I'm going to talk a little bit about this. You should be done with the chapters 1 and 2. No, I know you. Yeah, you should. If you're pacing yourself according to these due dates, okay, these highly suggested pacing yourself due dates, if you're pacing yourself through those, you should be done with chapter 2 in zyBooks, and you should be done with assignment 1. Okay, so I have uploaded the grades, and so you can go and see that what your grades are recorded, and the way I've done it is for the ones that are due, like assignment 1 looks like it's due, and participation 2 is due, and challenge 2 is due, and just the slab 1 is due. If you don't have scores there, I've put zeros. Now that doesn't mean you got zeros for the rest. It better not mean that you have zeros for the rest of the semester. Okay, it better mean that later on, sometime before the end of the semester, you'll go in and put scores in there. And the next time I do the grades, I'm going to really try to do the grades once a week. That's 6 times. So I do all the grades, and so when you get them done, you should see them being updated here. Okay, so don't put any mind to this. Why? Because I haven't. For me, I didn't do the third one here, and it doesn't look like I've done it. Oh, I can't. My textbook is under a different category, so I can't download the scores from my textbook. So these are always going to be 0, unless I steal somebody else's. Maybe I'll do that. But anyway, so that's the grade book, and that's how you can see that the scores in zyBooks get posted up here, and the scores in your autograder for the assignments get posted up here. Okay, so I'd like to I'm going to talk about assignment 2, and assignment 2 is highly related to chapter 2. So let's go to the textbook. And let's go to this chapter 2 here. Let's go to normal forms. And this talks about the different normal forms in tables, or the relational algebra term for it would be in relations. Or it's a table. It's got columns or attributes, and it's got rows, which are instances of that particular thing, whatever the table is representing. And the idea of normalizing your tables is to remove the redundancy. You don't want to have redundancy, because if you have redundancy, then you might, when you're updating or entering, it might be inconsistent. If you have a certain value, like a birth date, and it's in 2 places, in other words, it's redundant, then it's possible that they'll be not the same. And if they're not the same, that's integrity and the database is designed to keep redundant, to keep it so you don't need to store anything redundantly. So if you're storing somebody's birth date, it's only stored in 1 place, and all the places all over the place that the person's birth date is used draws from that 1 place that's is designated to store the birth date. So that's what redundancy means, and you don't want to have redundancy. And so you normalize them: first normal, second normal, third normal, BCNF, fourth normal, fifth normal. You normalize to remove redundancy. And sometimes you don't need to go that far because of the nature of your data. Okay. All right. So here's an example of redundancy here. As you got a table here, and it's got passenger number. It's a booking table, and there's a bunch of information about each booking. And look, the passenger number for Elvira is redundant. In fact, Elvira is redundant, and so on. The boarding zone for first class is in there 3 times, and so that's example of redundancy. Now, these are the normal forms. The greatest redundancy is first, and then we go down to voice cod, or third. Well, okay, you definitely want second. Okay, you definitely want to get to second. And sometimes you're okay staying in second, but then third. If you want to go to third, you need to remove that little bit of redundancy, and then voice cod comes after that. Fourth and fifth normal, it's those have to do with where using joins. There's a property called join dependency, and it's difficult to explain exactly how to define it, but you'll know it when you see it. You'll know when, oh, there's still look. You're going, well, this table is in voice cod, but there's still redundancy in there, so you got to reduce it more, and it's then that you know that you need to go further. Fourth and fifth. All right, so this talks about. Does it actually talk about multi-value dependencies? And yes, fourth. Okay, so first normal form. I guess it's this one. And join dependencies, multi-value dependencies, eliminates all the functional. Okay, so eliminates all redundancy arising out of functional dependencies. That's voice cod. But then after that, you've got multi-value dependencies, which I believe is this one. Yes, and fifth normal, it eliminates joint dependencies and associated redundancy. Okay, so the reason I bring this up is because assignment 2, the last two databases, you need to go further than voice cod, and when you see that, it'll be obvious. Okay, so first normal just means that all non-key columns depend on the primary key, either directly or indirectly. So there's a primary key, and that primary key can define. It defines what you can identify the entire row by that primary key. And so in this case, if you have a table of passengers, you can see the passenger number is the primary key. And then the passenger name is over here, and there can be 2 passengers with exactly the same name, but you distinguish them by their passenger number. With one problem with just plain old first normal form is that it's possible to have something like this, where you have the primary key. By the way, you only have to worry about if it's in second normal form or not is if it's a composite primary key. In this case, we have a booking, and a booking has a composite primary key. This is what the booking table reduces to. And then there's a passenger table over here. But if we just leave it this way, then we have the flight code. All of this stuff depends on the flight code, and the passenger name only depends on the passenger number. The passenger name does not depend at all on the flight code. But the booking itself, to uniquely identify an entire record in this table, you need both the passenger number and the flight code, because you can see, as you can see, Elvira here you see that Elvira is traveling on this flight, and so are these other two people. So anyway, so this table is not in second normal form, and so you reduce it to two tables, both of which are at least in second normal form. So you pull out the information where you have a non-key field depending on only part of the primary key. You pull that out into a second table, and that leaves the rest of the information in the table, where all the non-key fields depend on entirely on the primary key. Okay, so that's how you know that something is in second normal form. Everything depends completely on the key. Yeah. So all of the non-key fields depend completely on the primary key. Now, but this is not in third normal form. Why? Because in third normal form looks at just non-key fields. Okay, we're looking at just non-key fields. So to know if something is in third normal form or not, you look at the non-key fields. And if there's any dependencies between these non-key fields, then you know it's not in third normal form. You gotta pull that out into a separate table. So here, for example, the boarding number depends solely on the fare class, okay? First class is all boarding number 1, economy class is boarding number 3, and business class is boarding number 3. So we have this booking table, this fine booking table here, and it's in second normal form, but inside here you've got this thing depending on this. These are just non-key fields we're looking at. This depends on this. Well, that means it's not in third normal form. So you have to pull these two out, and you leave this one, and you pull this one out and make another table, a third table, which looks like this. We have the fare class is the primary key, and then this depends on this field, and these are actually, this is a non-key field in the booking table, but lo and behold, this is the primary key, this into the fare table, which is where you also can get the boarding zone number. Okay, so that's how you take something that's in second normal form and make it in third normal form. So you have no non-key fields depending on any other non-key fields. And then Boyce code, this talks about candidate keys, because like if you have like at like our UHID, we have an 8-digit UHID. That's a primary key. We also have our UH username for our email, and that can also be used as a primary key because everyone's got one and it's unique for everybody, pretty much. And you could probably also use social security number in there, and that's of course what we used to use back before we had our 8-digit UHIDs. All right, so this takes you through these exercises to make sure you understand about these dependencies, these functional dependencies. And then we have Boyce code, and Boyce code takes it one step further. Third normal just looks at non-key fields. Boyce code looks at all the fields. And if there are any more fields, if there are any more non-key fields that are dependent on anything, which can be maybe part of a primary key, then it's not in Boyce code. And so to get it into Boyce code, you take that redundancy out too. You make a separate table. So here's an example of employee project task, and you have this employee, and this is the project that the employee is working on. And so let's say, yeah, okay, this is the employee is working on a task. Okay, the employee is working on a task, and then but the project name depends on the task. Let's see, there must be some rule here about task and employee. task name, an employee, the employee ID, the employee ID plus the task defines the what the employee is working on, the employee task, but the project name, oh, never mind, here it is. There's a parentheses here. So we have this employee project task table, and the employee ID plus the project name is the primary key, but we have this other non-key field that defines, or that depends on the primary, no, that task name determines what the project name is. This is the task name. Yes. So the task name determines what the project name is, because the task name is. And so this task name means it's the performance reviews project. This task name means it's the training project. This task name means it's a training project, and so on. So this is in third normal form because we don't consider non-key dependencies based on only part of the primary key. We consider non-key fields depending on each other. And it's in second because because all non-key fields depend completely on the primary key. The primary key can determine the non. It takes the primary key in full to determine a non-key value. But here we have this non-key value that determines part of the primary key, and that's the problem. Why this is not in voice code? It's kind of confusing. So we reduce the redundant. We pull it out into a different table. We've got a new table here called employee task, and that is going to be the employee ID and the task name. And because the task name will determine the project name. The task name determines the project name. And I think our last assignment 6 and assignment 7 is a database like this. Sometimes so we'll see. So so there's a nice summary. Just make sure you understand that. Someplace, was there a summary around here of? Well, here's a nice thing for third normal. Redundancy can occur in a second normal form table when a non-key column depends on another non-key column. Informally, a table is in third normal form when all non-key columns depend on the key, the whole key, and nothing but the key. Sort of, anyway. All right, so that's the difference between these forms, and then we don't really go. This thing doesn't really go into fourth and fifth, but so let's go to. So I want to go to assignment 2. So let's go to assignment 2. Assignment 2. By the way, somebody asked me about. I mentioned this in the previous video. Somebody asked me about. Oh, in fact, a couple of people asked me about assignment 6, or no, the first lab in the first chapter, and installing the database on your computer versus using your own personal web server. And you don't need to install Sequila on your computer. You can just use your web server. And the video for showing that is in resources spring 2022 playlist. This one, first video. Oh, you got to wait till you. By the way, I have Tesla solar panels. And you go to 1530. Like 1530. Oops, 1530. Okay, so this tells you how to do that lab. This tells you how to do it, starting from logging into cPanel. In the end, in the end, you take what you got out of your PHP myadmin and you paste it into. So here it shows you how to import that create table statement, and you load it into. Yeah, so that's what you're going to copy. What you copy into there. Okay. Anyway, so let's go to that's enough of that. Let's go to assignments, and I'm going to go to what time is it? 10:20. Okay, half an hour. I'm going to go to normalization by projection, and okay, so these are simply these are tables that are in first normal form. Well, this one's in first normal form because what this is you have, this is the supplier parts database, which I used to spend a lot of time on this database, but I don't anymore. But you have these suppliers and their parts. The suppliers are shipping parts. The suppliers have parts in shipment, okay? These are the supply, this is the suppliers. This is supplier data. You have the supplier number, which is like the primary key, and then you've got a supplier name, and you've got some sort of status, and then you have some sort of city. Okay, those are suppliers. And then you have these parts. It's a part number, a part name, a color, and a weight. Okay, it's a parts table. And then you have the shipments. The shipments are, you've got a supplier shipping a part, and this is the quantity that they're shipping. Okay, so there's like 3 tables here. This depends on both the part number and the supplier number, whereas these 3 fields depend only on the supplier number, and these 4 fields, 4 fields, city, depend only on the part number. And so you have to reduce this into 3 tables. And I think I tell you what the tables are. Well, detailed instructions. Okay, and there must be a video. Do I have a, oh, here's a video. Great, what does the video say? Somebody's making money off my videos. So there I am. And I show you how to do, I don't know how many. This is a video I made back in 2020. So this could be, assignment could be slightly different. Anyway, so that's that. Okay, so that's pretty obvious. You take this table and you create 3 tables. One just has these fields. The second one just has these fields. And the third one has got this field, and this field. Okay. And you set up the links between the tables, the references, the foreign keys. You set all that up, and then you do these insert. The table's name is, you got an S table for the suppliers, you got a P table for the parts, and you got an SP table for the supplier parts thing. And you do this. You do this statement, this SQL statement. Oh, well, first thing you load this table up. You load this whole big table up into a table called original. And so then this takes these 4 fields, and you got to use the distinct because you want it to be a relation, or you don't want to have any redundant fields. See this, if you don't use the distinct, you'll get you know, S1 Smith 20 London, you'll get that 3 times because there's 3 of them in here. Oh, there's 4, oh, there's 5 of them. Ooh, there's 6 of them in there. All right, so so this is how you create the 3 tables. So this is pretty straightforward. This, you set it all up. This tells you detailed instructions on how to do that. This is the same kind of thing. You have employees. You have, oh, it's not quite the same. I think you have to create a zip table too, don't you? Yes, you do. You have this is 4 tables. You've got an employee table. That's these, this one, 1, 2, 3, 4, and then 5. And then you've got a project table that's got 1, 2, 3. And then you've got a tasks table or a employees working on projects table that's got the EID and it's got the PID and it's got the hours. Okay. No, it must have something else. Yeah, that's all it has. Because each one of these is separate. Yeah, so that it has those 3 things. And then the thing is if we were to have this table like this, our first instinct is to create a table that's got those 6 fields in it. But this table is not in third normal form because there is, if you look at the non-key fields, this and this is a non-key field. There's a dependency. There's a functional dependency. The city depends on the zip code. The zip code determines the city. Okay. So these zip codes here determine Honolulu. This one determines IAEA and so on. So if you know the zip code, then you know the city. So you don't need to keep the city field in the table that's got the employees. All you need is the zip code, and then there's another table you have the zip code which determines the city. So those are 4 tables, and again you do, you do the same as you do up here, where you do insert. You insert into the table. There's going to be 4 of them. I think I'm quite sure I tell you what to name them down here. I tell you what to name the database, and I tell you what to name the tables. And then you do these, distinct, name the fields, and got to be in the same order. Got to be in the right order from an original. So you create an original. Yeah, you create an original. All right, now so these are regular old. These 2, the first 2 are regular old tables that you want to get up into BCNF. Yeah, you want to get them into BCNF. This table here, you need to go higher than BCNF. Okay, this is a table. This is some fictitious restaurant who they make these meals. They will serve you meals, or they serve these dishes where but there's certain rules. Okay, there's certain main dishes, and depending on what the main dish is, only certain side dishes are allowed. Only certain side dishes are allowed. If you're ordering salmon steak, it comes with either mashed potato or white rice. Okay, it doesn't come with baked. You can't get salmon steak with baked potato. This is a made-up scenario. But the fact is there are multi-value dependency here, where salmon steak determines the side dish, but there's 2 of them. Beef steak determines the side dish, but there's 2 of them. Okay, and in fact, mashed potato can be served with either salmon steak or beef steak. Baked potato though only with beef steak. White rice only with salmon steak. Okay, so that's a dependency there. And then the same with the wine. You can only, with salmon steak, you can only have Pinot Grigio or Chardonnay. You can't have Pinot Noir. You can't have Cabernet Sauvignon. So beef steak, you can only have a red wine, and you can't have a white wine. Okay, so you can see there's another multi-value dependency here. We have salmon steak determines either Pinot Grigio or Chardonnay. Beefsteak, the two reds. All right, so now this table is in BCNF. Each row is different. There's no single column that can determine the rest. You can't say salmon steak there's multiple salmon steaks, there's multiple mashed potatoes, there's multiple of each of these wines. So this table is in BCNF. If you wanted to have a primary key and you didn't want to add any new columns and you wanted to have a primary key, it's a composite primary key with all three of them. Okay? So it's all key. It's all key. But you still have these dependencies between components of the primary key. So you need to reduce it. You need to reduce it further. You need to have one table that's got the main dish and the side dish, and then you have another table that's got the main dish and the wine. Those two tables also are all key, but that's where you have salmon steak, mashed potato, and you have salmon steak, white rice, and you have beef steak, baked potato, and you have beef steak, mashed potato. So that'll be at one table. And the fact that mashed potato goes with salmon steak, and the fact that mashed potato goes with beef steak, and the fact that white rice goes with salmon steak, and the fact that baked potato goes with beef steak, that is in one table and it's only in one place. Salmon steak and mashed potato is only in there once. Beef steak and mashed potato is only in there once. Okay, so that's one table. The other table, same kind of structure. You just have the main dish and you have the wine. Okay, and so you've got the fact that salmon steak and Pinot Grigio and salmon steak and Pinot Grigio, it's only in there once. And same with the other three. And so that's reducing this table into, I think it's fourth normal form. Fourth normal form. Fifth normal form is when when all combinations, it's defined by all combinations. This fourth normal form just means that for it to be valid, it's got to be in. So the way you get this back is you join them. If you join them together, you join the two tables together, and you get back this table. And if it's in fourth normal is defined where if you use that as a test to see if a particular record is in the set of valid records, and that's fourth normal form. Fifth normal form means you will, and I don't believe this is in fifth normal form, but when you join the tables together, that defines the set. All right, so this is the same kind of problem where the course defines the textbook, and there's more than one textbook for the course. The course ICS 101, this was a while ago, was using this textbook and this textbook, and then you have this ICS 120 or ITS 129 defines this textbook, or no, defines this textbook. Anyway, so it's a multi-value dependency with the textbook to the course. Instructors, it's also defined by course. Certain instructors cannot teach all courses, but there's certainly more than one instructor can teach a course. So we have Nakasone and Sita and Singer all teaching ICS 101. We have Nakasone also teaches this and this. Singer also teaches this, and Sita also teaches this. So we have a multi-value dependency there. So this would be fourth normal form because not all combinations. Okay, so you have two tables. You have a course instructor table and you have a course textbook table. Okay, two tables, and you put everything in there once. The fact that Nakasone teaches ICS 101, that only goes in there once. It doesn't go in there twice, and so on. Textbook ICS 101 determines the textbook. This only goes in there once, and if you join the two tables together, you get a bunch of combinations, and a record in this table has got to be in the joined table, but the joined table does not define this table. This table's got ones that are missing from the joined table. This can be thought of more as a fifth normal form because when you join the two tables, it defines the whole the set. It defines how they can be combined, how main dish, side dish, and wine can be combined, and it defines all possibilities, and that's what would be served. All right, so that's the motivation behind this assignment, and so that's what we're trying to get at here. All right, so that's assignment 2. What I'd like to do now is to start chapter 3. Okay, so here is our more or less our formal introduction to SQL, and this is, as I've said before, it's a very important part of this class is for you to be able to whip out SQL, for you to understand it all, understand the syntax, understand about closure, different ways of doing the same things, joining tables together. You know, we work hard to reduce the data down to the highest normal form necessary. Actually, it's the highest normal form. Go through the steps to reduce it to as high normal form as we need to, and then we need to use join statements to join all that back together again. And so if we have a case where you need to know the average birth date, the average age of everybody working on a project in Cincinnati, you have to write this big long SQL statement to get through the foreign keys all the way. You start with the project, go through the foreign keys down to the employee, down to the birth date, and so on. Then you want to average that up. You want to use an SQL statement that averages the ages together, computes the age, and then averages the age by using a group by in your SQL. That's what you presumably learned from this chapter. So this talks about SQL. This explains that SQL is not only interrogating the database, but also the statements to create the database. There's different terms for what that is, but the syntax of an SQL statement, which you've seen before, there's select statement, insert statement, update statement, and delete statements, and those are for interrogating the database and updating the database. This is all part of SQL, but these are the different sort of categories of sub-languages, they call them. This includes, creating the database and manipulating them and controlling user access and managing transactions, managing multiple users accessing the same database at once, so on. And so creating and dropping databases here, we have, this is section 3.2. These are the statements to create a database and to get rid of a database. We don't use MySQL create database statements so much in this class because we're using on our server, our web-based database management system, which is PHPMyAdmin, doesn't let you create databases directly in PHPMyAdmin. You have to use that other application called MySQL to create the database. Once the database is created, then we use PHPMyAdmin. But anyway, this talks about create database and drop databases. The show statement works in PHPMyAdmin. You can show, yeah, I think it does. It does. show databases, show tables, show columns, and so on. Show columns of a table, show tables of a database, show the create table statement of a table. You know, if you have a table there and you want to know what statement can be used to create that table, and so this is how you get that. Okay, what's three? Creating and dropping tables. Types. There's SQL data types, and these are all built-in data types in MySQL. We're using MySQL. And the nice thing about a database is once you define a field using one of these basic types, the database enforces that. It won't let you put anything in there that's not, that doesn't fit the definition. And so, you know, you can learn this and take advantage of that. Drop table. Let's go to the first add. These are for the alter table. Now, what's nice about our using phpMyAdmin is you do stuff by clicking and pressing the submit button. And what happens is before it does anything, or just after it does something, it shows you the actual SQL statement or statements that it used to do the thing that you asked it to do. And so you can find out, like, so if you want to find out this, you can go ahead and add a column of a particular data type to a table, and then you'll see that phpMyAdmin will tell you that this is the SQL statement that it used. All right, so this. All right, let's do this one. Okay, create a table named country. Okay, so we're supposed to type something here. Okay, create table country, I think. ISO code is consisting of 1 to 3 letters. I'll do, gonna be char or varchar. I'm gonna try char. 3. And population is a whole number. Unsigned int. Unsigned int. Is that right? Let me see. Let me go up here and small int. Okay, so it must be int unsigned. Int unsigned. All right, so I'm going to do int unsigned. I'm going to make it look like that, but I'll except I'm going to use int. So I'm going to say int unsigned. And I'm going to use varchar. I didn't see any var. I didn't see any chars up there. So let's see if this is it. This works. Oh, I didn't finish it. No wonder. All right. Oh, do I get to finish it? Oh, great. Is that right? Let's check. Drops a column name. This drops a table. Drop table. Drop table. Table name. Okay. Drop table name. All right, I got it. Okay, so you can do the rest of them. Okay, here's a lab. 10 points. Create a student table with the following column names, data types, and constants. Okay, so I'm gonna, you should try to do these on your own, but you can always use phpMyAdmin. Well, let's use phpMyAdmin. We can see how that works. R1 RICHARDH. Oh no, I gotta use the one. ICS321.com. There's my, okay, and I got to go to cPanel, and I'm going to go here, and it's our R1 CHA321. This one. Good. And so if I go to phpMyAdmin right now, and I look over on the left, I don't see anything but this information schema thing, which you can look at if you want to, but it's not really necessary for this class. So I'm going to create a new database called test, just to have, so I can create these things, okay? So I'm going to create a database, and I'm just going to call it test. Enter. Okay. Now, if I go back here, and let me try to see if I do this, does it work? Here's my test. So I'm going to go into test, and I'm going to go ahead and let me put this, does this work? Yeah. And I'm going to put this over here. Okay. So I'm going to create a student table with the following column names, data types, and constraints. So here I'm in here. Okay, and I don't need that. I'm going to create a new table, and I'm going to call it student. And how many 1, 2, 3, 4, 5, 6, 7, 8, 9, although you can always change it later, but might as well do this 9. And you got to fill in these fields, and the first one is going to be called ID, and it's a range from 0 to 65,000, auto increment primary key. Okay, so this should be unsigned because it can go all the way up to 65,536. So how do I do that? Int. How do I do int unsigned in here? I don't see how I can do that. Must be another name for it. Int, small int, medium int, big int. All right, well, maybe I can edit. I'll edit it afterwards, okay? I'll go with what they got here, and I'll edit it afterwards. It's auto increment. To make it auto increment, you see this AI, that's auto increment. You click that, it's auto increment, that makes it auto increment, yes, and it automatically makes it the primary key because that's the only reason you do that. So it's auto increment primary key, it's called ID. I gotta come back and fix this later. I don't think I can fix it now, can I? Any other attributes? Here we go, unsigned. Here it is right here, unsigned, okay, integer, unsigned primary. Okay, great. What's next? First name. Let's get this right. I must have done this before. First name. And max 20 characters. Varchar 20 characters. Not null. So we leave this unchecked. Next one is last name. Oh, look. Varchar 30. Not null, leave it unchecked. What's next? Street, S-T-R-E-E-T. This is going to be variable length string, varchar 50. Not null. City, variable length string 20. State, fixed length, that's char, 2 characters. Not null. Default Texas. All right. TX. Okay. Zip. Oh look, it's not in third normal form. Well, we're making a second normal form table here. That's nice. Integer. It's an integer between 1 and 6 million. I don't know. Is that a large int? Big int. I'm going to say it's big int, and it's not null. The zip and the phone is fixed length, 10 characters, not null, and email. It's variable length, 30 characters. Doesn't say not null. Must be unique. All right, I'm going to leave it. I'm not going to say that it can be null. It doesn't say that it's not null, but if it's going to be, it's got to be unique. I don't know if unique considers null or not. I'm going to say unique. Where's attributes? Is there attribute? Unique. Indexed unique. Okay. I wonder if this lets you be null. Can I do this? No. I'm going to say that it can be null because it doesn't say that it's not null. So I'm going to say that it can be null. See what happens. All right, so that's it. And I'm not going to bother with the storage engine. And I'm going to preview the SQL. Let's do this. I'm going to preview the SQL. And this is what the SQL looks like previewed. And so let me, you know what I'm going to do? I'm going to copy this. Although I don't need the engine, but I'm going to copy it anyway. Copy, and let me put it over here. Oh no, or over here. I'm going to try to paste it. It doesn't look very good. All right, yeah, I'm going to have to mess with this a little bit. First of all, it can't be. We're supposed to call it student. So let's get rid of this first part here. We don't need this. We don't want this. Oh, I don't need to do that. And then we have this one. First name, last name, street, city, state, zip, phone, email, primary key ID, unique email, and this, do this right there. And these can be indented, but they don't have to be. Okay, so I'm going to see, and I'm going to take this engine off. I don't have to worry about that engine. Okay, so I'm going to see what this does. Submit. To see it work, you got to hit submit. You can do it as many times as you want because this isn't going to. If we just hit development mode, it's not going to show us anything. We have to submit it for grading to see if it worked, if it's correct. And I wonder if this null thing is going to cause me problems. It's 11:08. Oh, all right. Let's see. Doesn't like this. Ah, it wants to see. Oh yeah, right. 65,536 only requires 2 bytes, and I said it required 4 bytes. Int10 is 4 bytes. So anyway, that's wrong, and it does not like. It should be no. Oh, medium int unsigned. Okay, so all right, so I got to fix ID and I got to fix zip. And I think I got to do. All right, let's do that first. Let's fix the ID, and ID has got to be small int, and this is medium int. Unsigned. Okay, that was here. So I'll close this. Not quite right. Small int. And zip is medium int. Okay, medium int. And what else did it not like? Is that it? Okay, small int and medium int. Small int 5, medium int 8. Let's go back to this and change, see if I can fix this. Small int. I bet I don't have to put the 8. Medium int. Okay, what does this do for me? And 8 out of 10. What did I not get right? Medium int. Ooh, unsigned. I should have said unsigned. Okay, the zip has got to be medium int unsigned. Really? 8 unsigned. Okay. Unsigned. Okay, let's try this. So anyway, I hope you just skipped to see the final result here. But anyway, so I got all the points. And so that I've taken you through lab 3.4 and gone over assignment 2. And I hope this helps. Thanks for watching.